In this lesson, we're going to look at more examples of using dimensional analysis. Specifically, we're going to look at how we convert values among units. Let's look at an example using the metric system. How many milliliters in 4.3 liters? So our starting units are given in the problem as liters because that's the only numerical value we have in the problem. For our answer, we want units of milliliters because the problem asks how many milliliters. And then we have to look at the relationship between liters and milliliters. And so this is based on the metric prefix. So we say 1 milliliter equals 10 to the minus 3 liters. So the way to remember how to set up those metric relationships is put the 1 with the prefix and put the meaning with the base. So in this case, the base unit is liters, and so we've put the meaning of milli, which is our prefix, we've put the meaning of milli with the base unit. So we put the 1 with the value with the prefix, so in this case milliliters, equals 10 to the minus 3 liters. Next, we're going to start our problem. We know we're starting with our 4.3 liters. I'm going to set up my parentheses, and what I see is that liters is going to go on the bottom because I want to cancel out liters with the numerator from the first value, the 4.3 liters. So if liters is on the bottom, milliliters goes on top. Notice that the number, the 1, stays with the milliliter, and the 10 to the minus 3 stays with the liter. We always make sure the number stays with the unit it started with. Next, I can cancel out liters, and then I can solve the problem, and when I put this in my calculator, I get 4,300 milliliters. And when I round that to the correct number of significant figures, I have 4.3 times 10 to the 3 milliliters. So I want to avoid the 4300 because those last two zeros are ambiguous as to whether or not they're significant. Next, I always want to ask myself this final question: is the answer reasonable? So we're not as familiar with the metric system in the US as they are in the rest of the world, but we can think a liter is about a soft drink. So you can think of a 2-liter soft drink, and we know that a milliliter is really small. It's about the size of a playing die. So it's going to take a lot of milliliters to fill up that 2-liter bottle. And if we had two 2-liter bottles, so about 4 liters, it's going to take twice as many. And so I know I'm going to have a lot of milliliters to fill up that 4.3 liters. And so it seems reasonable that we'd have a large number for the answer. Again, in this problem, I have units with all of my numbers. I go through and cross out those units. Even for as long as I've been doing chemistry, when I solve problems, I still go through and cross out units. How many inches are in 6.814 meters? So in this case, we're given starting units of meters because that's the only numerical value in the problem. And we're trying to find inches, so how many inches? Now in this problem, I don't know a direct relationship between meters and inches. There is a relationship, and if you know that, you can use that one. I'm going to show it a little bit different method because what I'm going to show is that we're going to go from meters, then to centimeters, and then to inches. Because the centimeter to inches relationship is one that I know and that I use often when I'm going between the metric system and the English system. So I say 1 centimeter equals 10 to the minus 2 meters. Again, I put the 1 with the prefix, so the 1 with the centi. And the meaning, 10 to the minus 2, is the meaning of centi with the base unit. The base is meters in this case, so the base unit never has a prefix in front of it. So 1 with the prefix, put the meaning with the base. Now I need another conversion, which is 1 inch equals 2.54 centimeters. And I find this particular relationship to be very useful. It's also important because 1 inch equals 2.54 centimeters is an exact relationship. That 2.54 is not a rounded number. While much of the time our exact numbers are whole numbers, in this case it is not. This is an exact number, which means we do not include this when we're looking at determining significant figures for our final answer. So now we can set up the problem. We start with our 6.814 meters because that's our given value. We have meters in the numerator, so we need to have meters in the denominator, and we're going to put the centimeters on top. Notice the 1 stayed with the prefix, the meaning with the base. The meters is on the bottom so that our units will cancel out. Now if I stop the problem here, I'd have my answer in units of centimeters. So now I need centimeters on the bottom of the next step. So 2.54 centimeters is equal to 1 inch. And again, the relationship, 1 centimeter is 10 to the minus 2 meters. 1 inch equals 2.54 centimeters. Those relationships are true regardless of what value I'm starting with. So we always want to make sure the relationships are true as we put them into the problem. We don't change these values because we're starting with a different number. Now I can cancel out centimeters because I have it in the numerator and the denominator. At this point, I'm left with units of inches. I solve the problem and I find 268.3 inches. And I see that this does have the correct number of significant figures because I have 4 significant figures in my answer. I have 4 significant figures in 6.814. Neither of my relationships have values that are going to contribute to significant figures because all of these values are exact numbers. All of our meanings based on metric prefixes are exact, and 1 inch equals 2.54 centimeters is an exact value. So our answer is based on the number of sig figs in our original number. Then we want to ask ourselves, is the answer reasonable? A meter is approximately 1 yard or 3 feet, and 3 feet is 36 inches. If I have almost 7 meters, that's about 7 yards. And so I see that I'm going to have a large number because 7 times 36 will be a large number. So this is a reasonable answer. If I had gotten a value that was 0.2683, that would have been a sign that I had the wrong setup. I made a calculation error, that there was something wrong in my problem. So in this case, I see exactly what I expect to find, a fairly large number relative to the number that I started with.